Let's do one more. One more, walking you through the phantoms, if you will. Let's get that marker on there. Phantoms, and then we will call it a day for this section. An educator estimates that the dropout rate for seniors at a public school in California is 11%. Last year, 25 seniors from a random sample of 200 California seniors withdrew at an alpha level of 0.05. Note, this is indicated. Is there enough evidence to reject the educator's claim? Okay, so we're looking at our null hypothesis. Let's assume that they're right, that the dropout rate in California is 11%. What we found from our statistic, or our sample statistic, is 25 out of 200, or 0.125. Our sample size was n, our alpha level was 0.05. So we're looking, doing this methodology, is the p-value that we get, the probability that we got this sample, is it less than 0.05? So first off, let's identify the parameter. The parameter that we're looking at is the proportion of students dropping out, with our null hypothesis being that the teacher is right. The null hypothesis is that the dropout rate is 11%. Our alternate hypothesis is it's not that. I don't know if it's larger or smaller. It could be smaller. So we're going to look at a two-tailed test. Okay. So we have our hypothesis. So I suggest that we go to the calculator first to help us give us an idea of where this is going. So what does the calculator give us? We're going to go menu, statistics, confidence, and we're going to go to tests, and we're doing a one prop z test. Let's guide our thinking. So we're at 0.11. We know that there was 25 out of 200 that dropped out last year. We're seeing if this is not equal to it. We run our one prop z test on our calculator, and we get a z-score of 0.6779, a p-value of 0.49. Our p-hat was 0.125, and n is 200. So let's keep that in the back of our mind that we get these data. You can see the results that I get here. Okay, we wrote out a parameter, A. We did our hypothesis test. We're going to check our assumptions and conditions. The sample was randomly collected. It said that. Students' records are independent. Yeah, if you drop out, it's going to be your choice, not someone else's. 200 is assuredly less than 10% of the high school students in California. NP is 25, and NQ is going to be 175. Both are greater than 10. So we can move on. So the T is to name the test. We've met the conditions. So to ensure a normal model of 0.11, comma, the standard error of our null hypothesis, which is square root of 0.11 times 0.89 over 200, will give us 0.0221. Just in case you need that calculation, I have it run here. So we're going to run a one proportion z-test with an alpha level of 0.05. Notice that I'm including all of the information that you need. We're going to do an inverse normal for 0.05, which is just 1 minus alpha over 2. 0, 1, so we get a critical value for a z statistic of a 1.96. Should sound familiar. We're doing a two-tailed test, so I draw myself a picture. Now notice you have the choice of doing the normal model, the standard normal model, or our specific model underneath. It's your choice. And what we're saying is, what are the chances that we're underneath here? So next, we're going to obtain our results. So we have our sample. We're going to calculate our z statistic. So what is the z-score? P hat minus p over the square root of pq over n. So 0.125 minus 0.11 over our standard error for our null hypothesis, because we're assuming that that's going to be the center. So we get 0.687, which is what we got from the calculator. So we're asking, what is the probability that we get this? Which is from our one prop z test, and we got 0.4978, or roughly 50% chance that 25 seniors out of 200, a different sample of 200, drop out. Now we're going to compare. Is 0.4978 less than 0.05? Nope. And so since our p-value is greater than our alpha level, and our z-score is less than 1.96, which was our critical value, wasn't it? We fail to reject the null hypothesis. So with our conclusion, there's not sufficient evidence to reject the educator's claim of 11% dropout rate. So in other words, there's not enough evidence to claim that the dropout rate is different than the 11% that this teacher proposed. I know that that's a lot. So we now have a z-test, we have phantoms, and we have a z-interval, which is panic. So the rest of this week, we're going to just work on practicing coming up with hypothesis testing. Now, note we're on one prop z-tests, one proportion z-tests. We could have two proportion z-tests, or we could have one prop t-tests or two proportion t-tests. And those are for quantitative data. So the rest of this year, we're going to be living in this hypothesis testing land. So we need to be good at this skill. All right. Thank you for being patient with me, Falcons. I will see you in the next one.